Okay, so let's talk now about how things oftentimes really are. Oftentimes, we don't actually get everything we hoped we were going to get. Of course, right? So when we measure that as chemists, we measure what we actually got and what we thought we were going to get, okay? So now, if we take let me get my marker here. If we take a balanced reaction, A plus 2B produces 3C, and suppose we start out with A and 2B, we theoretically are going to make 3C, but we might not, right? Now we're going to get our theoretical yield based upon our stoichiometric coefficients. If I start with 1A and if I start with 2B, then theoretically I can make 3C, but oftentimes I don't. Oftentimes I make slightly less than 3C. All right. And so if I make slightly less, it could be because of competing side reactions. It could be because they didn't all react like I hoped they would. It could be because of difficulty of getting the C out of the jar that I made it in, or losing it in filter paper or something like that, right? So difficulty recovery of product. So these are three reasons why I might not actually make everything that I was hoping to make, okay? So percent yield now is the extent to which a theoretical yield is achieved. Is That's the extent to which a reaction's theoretical yield is achieved. In other words, it's the actual. I don't know if I said that right. Can I start that one over again? Percent yield is what you actually got compared to what you were hoping to get, right? And we oftentimes say it in terms of percent. So we'll change the form of it to make it like that. In the previous example, we were talking about sandwiches. And we knew that with the 20 pieces of bread and 11 pieces of cheese, we could make 11 sandwiches, right? But suppose we only made 10 sandwiches, right? Then our yield, let's change this to a percent form. Our yield then would be about 91%. If you take 10 and divide by 11, you'll see it comes to 0.91, I think, or 0.909. So that is our percent yield then is going to be what you could have made. Let's see, what you actually made divided by what you could have made, right? When calculating percent yield, both yields must be expressed in the same units so that the units will cancel, right? So up here I had 10 sandwiches and 11 sandwiches. I might do grams per grams or moles per moles, right? Okay, so let's come and do an example. And I'm going to take this and let's set it up. Suppose we've got copper sulfate and we're going to react it with zinc and make copper. And I oftentimes put mass in my first row. We always need moles, so I'm going to use grams per mole to make my conversions. And here's my moles here, right? So suppose that we took 1.27 grams, or 1.274 grams of copper sulfate, 1.274 grams of copper sulfate with excess zinc. So we have as much of that as we possibly could want. So in this case, this is the limiting reagent, right? And suppose that in the end, we actually only made 0.39 actual 0.392 grams of copper, right? Well, what could we have made? So the way that we find out what we could have made, that's the theoretical, right? Theoretically, we could make, and the only way to get there is by comparing moles of this to moles of that, right? Because we only know it's a 1 to 1 to 1 to 1 ratio. We don't know the ratio of mass to mass. So I've got to go this way. All right, so first of all, let me calculate the moles of copper sulfate. Let me get a different color. Come over to my periodic table, which is here. And copper is 63.546, okay? 63.546, that's the copper. Sulfur is 32.066. 32.066, right? I know, my handwriting's terrible. 32.066, and my oxygen is 15.999. 15.999, and there's 4 of those, okay? So I've got to multiply that by 4, and we add all these together, and we get. And when I'm done with this, I'm going to actually Google it to check it. I'm going to Google all the time. Obviously, I can't Google on a test, but the more I do this in practice, the more I'm sort of verifying that my work is good. So 63.546 plus 32.066 plus 4 times 15.999 equals, and I'm going to get 159.608. 159.608. And I know my copper is there, right? So I can write that one in too. 63.546. 159.608, right? And so, and I'll be able to get my theoretical yield that way. Now, before I move on, I'm going to Google this. And it's going to be about 160, right? Molar mass of copper 2 sulfate. Molar mass of copper 2 sulfate, yep, is 160 right there. Okay, good. So, verified that. Let's go back over here. 159, I said 0.608 according to our periodic table, and that's what we're going to use. So how many moles is that? Well, it's going to be 1.274 grams. Right? See, my grams will cross off this way, and I'll get my moles of copper sulfate. So 159 point, that's on the bottom. 1.274, got to check that. It is 1.274, yes. 1.274 divided by 159.608 equals 7.982 times 10 to the negative 3. 7.982 times 10 to the minus 3 moles, right? Oh, this is a 1-to-1 ratio. So I'm just going to write this over here, 7.982 times 10 to the minus 3, because it's 1-to-1, right? Now I need to know what's my theoretical yield. So if I want grams of copper, theoretically, I can do grams per mole times my moles. Well, here's my moles. I'm going to call this X because I don't want to write it again. It's too bulky. And this is 63.546, right? So I'm going to take my 798 times 10 to the negative 3, and I'm going to multiply it times 63.546. And I'm going to get 0.507, 0.507 to, I'm going to say 3, okay? Get 5 sig figs. And my actual was there, right? So now I'm ready to do it. I'm going to do this in orange. I'm going to change colors. So my percent yield then is 0.392 divided by 0.50723, and this has 3 sig figs, okay? So I'm only going to report my answer in 3 sig figs. This one has 5, right? It was actually limited to 4, right? I had 4 here, so this could only have 4, but I put all those digits out there. And this times 100% equals, doing it on my calculator right now, 0.392 equals 77%. 77%. Oops. 77.3%, right? We're going to do it to 3 sig figs. 77.3%, and that is my percent yield. All right, so it's a little bit fast, and of course my board work is not beautiful, but it's a video. You can rewind it and look at it again. Hopefully that's helpful. We'll be doing more of these in the near future.